All right, more notation for the derivative. So here we've got some point information. When it says fg prime at 1, what this is saying is take the derivative of f times g and then put in x equal 1. So let's go find the derivative of f times g of x. So f of x times g of x, taking the derivative, right, is going to be first d second plus second d first. Okay, so now I'm going to do fg prime at 1. So now I'm communicating to my reader. Now I'm putting in the 1. Before, this one here, I could have said fg prime at x, right? Or written it like this, however. So now I'm going to plug in x equal 1. And use my puzzle information to see what number I get. Plus g prime of 1 is... Oh, what did I do? I think I made a mistake. First d second plus second, that's not supposed to be primed. This one's supposed to be primed, right? Okay. That one's supposed to be primed. First d second plus second d first. Yes, okay. First d second plus. So g of 1 here is 3, and f prime of 1 is 6. So I get a -4 plus an 18, so that gives me a 14. Okay, so same thing here. So this is going to be quotient rule, right? So let's do it. So I'd have low d high minus high d low, square the bottom, and off you go. All right, so now to evaluate it at 1, so f g prime at 1, it's going to need to write more out, right? So I'll have g of 1, f prime of 1, f of 1, and g prime of 1 all over g of 1 squared. So putting all the puzzle pieces in gives me 3 times 6 minus a -2 times a 2, and then g of 1 gave me a 3 squared. So I get 18 plus 4 over 9. So 22 over 9. All right, last couple here. So here my capital F of x is given this product here. So they want me to find capital F prime of 1. So let's first find the derivative with respect to x. So that's first d second plus second d first. Okay. So they're saying use, you can see inside here, they're telling me to put in x equal 1. So you put x equal 1 everywhere. Don't let that be confusing. So put x equal 1 everywhere. So that'll be g of 1 e to the 1 power plus e to the 1 power g prime of 1. So g of 1 gave me 3. G prime of 1 gave me -2. So I have 3e minus 2e, so that gives me e. All right, last one, I think. Yes, last one, okay. So this is asking you to put together a function that does all of these things on one graph. So first let's scope out what numbers I've got. So I've got infinities, 5, and 1, okay. So I don't really need back in the negative land, so there's 5 and 1, okay. So let's see what this is saying. N behavior, as I'm going out to infinity, I go to the y value of 4. And n behavior, as I'm going to negative infinity, I go to the y value of -3. Okay, got those two taken care of. So what's happening here? So let's look at what's happening towards 5. So it doesn't say one-sided, it's from both sides. So if I'm coming towards 5 from both sides, I'm going to the y value of 2. So I'm just going to have it go there, and I'm just going to put an open circle for now. Get rid of those little red lines. Oh, and then they even tell me what the y value is at 5. It's 3, so it's a good thing I left an open circle. Okay, so that's what's happening near 5. And I don't have anything more happening out here, so I'm just going to join it together. Okay, So now what's happening towards 1? So if I'm going towards 1 from the positive side, right? 1 from the positive side, I go to the y value of 4. If I go to 1 from the negative side, I'm going to the y value of 3. And then when I plug in x equal 1, I get the y value of 3. That's what that's saying, right? Okay. Oh, now it's giving me some derivative information. Okay. So let's talk about what this one's saying. So this is saying at x equals 0, the slope of the tangent line is 0, right? This 0 is this 0. Okay. So that means I must have a continuous graph with no cusp corner or bad things happening at x equals 0. So it doesn't tell me what the y value is, right? Nope, it just says the derivative is 0. So I have this part of the graph, so I'm just going to have it come up, make a flat spot, right? And then come up to here, right? Oh, maybe I should make it a function, right? So maybe I'll make it a little different. So maybe, oops, maybe it's coming out here, so maybe I'll have it at 0 like that, right? And then join together here so that it fits together to be a graph. All right, so this is saying at, oh, I might have to erase, lots of erasing. Plus this isn't a function, so I need to fix this. Okay, so there's my slope, 0, -1. Okay, so this says at -1, the y value is -2. Okay, so there's a point there. And the derivative doesn't exist. Ooh, we have options, right? So I know this has got to go out to be a vertical asymptote up here. So I'm going to have it come down. Oh, I know. I could do a vertical tangent and then have it come out that way. So make a vertical tangent, and that would make the derivative not exist. So that's one of many graphs. So let's see, we join this one together where it can be joined together. And that's one graph.